Ever notice how time seems to fly by when you're having fun, or how it drags on forever when you're bored? That's time for you, always changing, always relative. But did you know that time isn't the same everywhere? It's true. Out in the vast expanse of space, time behaves in ways that seem like something straight out of science fiction. Get ready to explore the mind-bending world of time travel, Space Edition. Fasten your seatbelts, it's going to be a wild ride. What is time anyway? It's something we experience every single day, yet it's hard to define. We can't see it, touch it, or smell it, but we know it's there, ticking away relentlessly. Time is like a river, constantly flowing from the past, through the present, and into the future. We measure time in seconds, minutes, hours, and years. We use it to schedule our days, plan for the future, and mark important events. Time is the fabric of our lives, connecting us to the universe in a profound way. Here on Earth, we're used to time behaving a certain way. A day is 24 hours long because that's how long it takes our planet to rotate once on its axis. A year is 365 days long because that's how long it takes Earth to orbit the Sun. This predictable rhythm of days and years governs our lives, from the changing seasons to the cycles of day and night. It's our earthly clock, and we're all living by its beat. But here's where things get really interesting. When we venture out into the vast expanse of space, we encounter phenomena that challenge our everyday understanding of time. Out in space, far away from the gravitational pull of Earth, time doesn't follow the same rules. It's a concept that has fascinated scientists and philosophers for centuries. The further we move from Earth, the more we realize that time is not a fixed entity. It's not constant, it's relative. What does that mean? Well, it means that time can be experienced differently depending on various factors. This idea was first brought to light by Albert Einstein with his theory of relativity. It means that time can speed up or slow down depending on how fast you're moving or how strong the gravitational field is around you. For instance, near a massive object like a black hole, the gravitational pull is so strong that it can significantly warp time. Imagine two identical clocks, one on Earth and one in space. If the clock in space is moving at a high velocity, or is in a different gravitational field, it will not tick at the same rate as the clock on Earth. The clock in space wouldn't tick at the same rate as the clock on Earth. This phenomenon is known as time dilation. It's a fascinating concept that has been proven through various experiments and observations. It might run a little faster or a little slower depending on its location and speed. For example, astronauts on the International Space Station experience time slightly differently than we do on Earth. Their clocks run a bit faster because they are further from the Earth's gravitational pull and are moving at high speeds. This effect becomes even more pronounced near extremely massive objects. Near a black hole, time can slow down so much that what seems like a few minutes to an outside observer could be years for someone close to the black hole. Einstein's theories have been tested and confirmed through numerous experiments, including observations of atomic clocks on airplanes and satellites. These experiments have shown that time dilation is not just a theoretical concept but a real phenomenon that affects our daily lives. Understanding time dilation has practical applications too. For instance, the Global Positioning System, GPS, relies on precise time measurements. Without accounting for time dilation, the GPS would be inaccurate, leading to errors in navigation. So the next time you look up at the stars, remember that time up there is not quite the same as it is down here. Space is a realm where time gets wonky, and understanding this helps us unlock the mysteries of the universe. Section 5. Gravity's time warping power. One of the things that can affect time is gravity. This might sound like something out of a science fiction novel, but it's a well-documented phenomenon in the realm of physics. Gravity doesn't just keep us anchored to the Earth, it also has the power to warp time itself. Imagine a clock ticking away in the vastness of space. As it approaches a massive object like a planet or a star, the ticking slows down. This isn't just a trick of the eye, it's a real effect that has been measured and confirmed by scientists. The stronger the gravitational pull, the slower time runs. This phenomenon is known as time dilation. It's most extreme near incredibly massive objects like black holes. Near a black hole, the gravitational pull is so strong that time can almost come to a standstill. If you were to observe a clock near a black hole, you would see it ticking slower and slower as it gets closer to the event horizon, the point beyond which nothing can escape the black hole's pull. This mind-bending concept is a key part of Albert Einstein's theory of general relativity. Einstein proposed that gravity is not just a force pulling objects together, but a curvature of space and time itself. According to his theory, massive objects cause a distortion in the fabric of space-time, and this distortion affects the passage of time. The closer you are to a massive object, the more pronounced this effect becomes. Think of it like this: gravity is like a giant cosmic mattress. When you place a heavy object on a mattress, it creates a dip. The heavier the object, the deeper the dip. This is a simple way to visualize how gravity works in the universe. The fabric of space-time is like the mattress, and massive objects like stars and planets create dips in this fabric. A massive object like a planet or a star creates a dip in the mattress. Smaller objects like moons or satellites move around in this dip, following the curvature created by the massive object. This is why planets orbit stars and moons orbit planets. They are all moving along the curves in the fabric of space-time created by gravity. The deeper the dip, the stronger the gravitational field. This means that the closer you are to a massive object, the stronger the gravitational pull you will feel. This is why astronauts experience weightlessness in space. They are far from any massive objects, so the gravitational pull is weak, and the stronger the gravitational field, the slower time moves. This is why time passes differently for astronauts on the International Space Station compared to people on Earth. The ISS is in a weaker gravitational field, so time moves slightly faster for the astronauts. This effect is tiny but measurable, and it has to be taken into account for precise operations like GPS satellite navigation. It's like time is climbing uphill, struggling against the pull of gravity. The stronger the gravitational pull, the steeper the hill, and the slower time moves. This fascinating interplay between gravity and time is one of the many wonders of our universe, revealing just how interconnected everything truly is. Section 6. Speed Demons and Time Travelers. But gravity isn't the only factor that can mess with time. Speed also plays a role. The faster you move through space, the slower time runs for you relative to someone who is stationary. This is another mind-boggling consequence of Einstein's theories. It means that if you could travel at the speed of light, time would essentially stop for you. You would become a time traveler, whizzing through the universe while everyone else ages at a normal rate. Section 7. GPS proof that Einstein was right. You might think these effects of time dilation are too small to matter, but they're not. In fact, engineers have to take them into account when designing GPS satellites. These satellites orbit Earth at incredibly high speeds and are farther away from Earth's gravitational pull. As a result, time runs slightly faster for them than it does for us on the ground. To compensate for this, engineers have to adjust the clocks on GPS satellites ever so slightly so that they stay synchronized with clocks on Earth. Section 8. Time travel, fact or fiction. So, does all this mean that time travel is possible? Could we build a spaceship that could travel fast enough to propel us into the future? It's a question that has captivated scientists and science fiction writers for decades. While we haven't quite cracked the code of time travel yet, the laws of physics don't rule it out entirely. Perhaps someday we'll find a way to navigate the cosmic currents of time and unlock the secrets of the universe's past and future. Section 9. So time and space. Totally different. Time and space is a wild, wacky, and wonderful concept. It's relative, it's flexible, and it's constantly being shaped by the forces of gravity and motion. Imagine a place where the rules of time as we know them are completely different. In space, time can stretch and compress in ways that are almost unimaginable to us here on Earth. Next time you look up at the stars, think about how the light you're seeing has traveled for millions, sometimes billions of years to reach your eyes. You're essentially looking back in time, witnessing the universe as it was eons ago. Remember that time up there isn't ticking by the same way it is down here. For instance, astronauts aboard the International Space Station experience time slightly differently than we do on Earth. Due to their high speed and the weaker gravitational field, time actually moves a bit slower for them. The universe is full of surprises, and the way time behaves is one of its most intriguing mysteries. Black holes, for example, have such strong gravitational fields that they can warp time itself. Near a black hole, time can slow down to a crawl, making minutes feel like hours or even years. The nature of time is just one of the many mysteries that continue to fascinate and inspire us. Scientists and researchers are constantly studying these phenomena to understand more about our universe. The more we learn, the more questions we have. and the more we realize how much there is still to discover. Keep exploring, keep asking questions, and who knows what other secrets the cosmos holds. The journey to understanding time and space is just beginning, and it's a journey that promises to be as endless and fascinating as the universe itself.